Alright, so now we need to have the state diagram for a sequential circuit that does the following. When the input sequence is either 1, 1 or 1, 0 on the two preceding clock cycles, then on the next clock cycle R is 1, otherwise R is 0. Okay, so we're looking for either 1, 1 or 1, 0. So we want to think about what are our paths towards getting either of those. So the first thing is having a 1, that gets us somewhere. Having a 1, 1 gets us somewhere. Having a 1, 0 gets us somewhere. So if the last bit is 1, if the last two bits are 1, 1, or if the last two bits are 1, 0, then on the next clock cycle R will be 1. So we'll have our states, so we can have reset, and our output will be 0. And then if we get a 0, we'll come right back here because none of these have as an option their last bit is 0. If we get a 1, we'll go to our first state and call that A, B, C. And state A, oops, state A, our output is still 0 because we have not gotten 1, 1 or 1, 0. If we get a 1, we'll go to state B, and if we get a 0, we'll go to state C. Both of those, our output is 1 because those are both target, 1, 0 or 1, 1. Okay, so now let's think about what happens if we're at 1, 1 and we get a 1, we get another 1. Well, our last two bits are still 1, 1, so we'll come back here. If we get a 0, so we had 1, 1 and now we get a 0. Well, now our last two bits are 1, 0, so we'll go over here to state C. And if we are in state C, that means we had a 1, 0. And so if we get a 1, then the only thing we have that matches is this first state A where the last bit is 1. So if we get a 1, we'll go to state A. And if we are in state C, that means we have a 1, 0. And if we get a 0, we're going to go all the way back to reset because getting a 0 doesn't help us any. Alright, let's see. A slash or something here with each of those. I'm just checking this, make sure it's right, make sure I didn't make any mistakes. Looks good.